Hey, Chris Kuzmal here again. So last time we discovered that we strongly suspected that the decrement of start and end here were the cause of our problem. The reason we decremented start and end was that made it so that we thought that our quicksort would be compatible with the quicksort specified in Corman-Liserson and Revest, even though our partition is not. Well, that's really a kind of a mismatch. And so what I've decided to do is to get rid of those decrements, and instead we're just going to use our own specification of quicksort, where you need to pass 0 and 3 uh, into the array. Okay, and so now into the quicksort invocation. And so with those two small changes, we now believe that we have our own specification that just has the values of start and end at one less than are used in Corman-Liserson and Revest, but we don't try to go back and forth between Corman-Liserson and Revest's specification and our own. So let's see whether or not that fixed it. So we click run, and the good news is that our code doesn't produce an error. The bad news is it looks like it's going on an infinite loop. Okay, and we see that our output, a print output, had a start of 0 and an end of 2 before it basically froze. Okay, and so what could be going on there? Well, I don't know. I do suspect that there's a termination condition that's not quite the way that it should be. So let's see what the story is. If I have an array that contains 1, 1, 3, 4, and I invoke quicksort with an argument of 0 and 2. Let me double check that that's what I think is going on. Yeah, and then that's going to invoke a call to partition, but we never come out of that call to partition. So the partition is also going to be of that same array and 0 and 2. So what happens when we have 0 and 2 as our partition? I'm a little concerned about that, the fact that the end value is 2 here. I suspect that I'll want that end value to be 1 less, and I'm tempted to just do that overtly here as an extremely lazy fix. Okay, lazy fix because I think it is right. Okay, so I was going to say added the subtraction here, but that's sort of confusing. So I'm going to inserted the -1. Okay, as my quick and dirty fix. So I click run just to see what happens, and I've got good news and I've got bad news. The good news is things didn't crash. The bad news is the thing still failed, and it failed in the same place. And that's a little bit surprising because I would have expected that the portion of the array 1, 1 was going to get sorted. I mean, it was going to get partitioned successfully. Why not? So now this makes me want to go back to my test code and give it this exact set of arguments and see whether or not it behaves correctly. So I can do that, okay? That's something I can do. So I'm sort of regretting not having my other test code all the way along here to help me out. But, you know, maybe it's still not the wrong thing to have done. Let's go back to here we are back to our other test code, our other partition code, and we're running it to see whether or not it runs successfully. It's giving me a hello world, but it's stopping. Sort of like is it also somehow deciding that it's gonna hang up on us? That's a little suspicious. It's making me wonder whether or not there's a problem with the REPL interface. I stop it, I run it again, and this time it passed. Okay, that does not fill me with confidence, right? Makes me want to try and run this a second time, but it doesn't seem to change its behavior. So we'll go ahead and assume that we have a problem. And the test case we're interested in is an array 1, 1, 3, 4, and do with a start of 0 and an end of 1 for our partition. So we can add a partition test 7, which can be very similar to partition test 5. Okay. I copy that code. And again, we're seeing a motivation for doing some better encapsulation here. Because a lot of this code, a lot of this code is sort of duplicated, right? And so our input array is 1, 1, 3, 4. We've done partitioning, and incidentally, the partitioning has already sorted the array, but that's kind of neither there. P is 0, R is 2, I believe. That's what we had. Let's go back and take a second look. No, oh no, n was at 1, and okay, and that kind of index 0, index 1. Yeah, I can buy that. And so then our expected result would be still 1, 1, 3, 4, and that's true for both of the results. So there's only one option, and so expected 1 and expected 2 will be the same. And so that looks like partition test 7 is correctly written without error, and it doesn't introduce compiler errors. And so now we'll add partition test 7 to our test suite that is invoked. And now when we run, does it work? Oh my gosh, it looks like it's hanging. All right, so that's good news and it's bad news. It means that we have indeed isolated the problem down to a partition test, to partition failing in a situation where we didn't expect it to fail. Okay, so the good news is we've isolated the problem. The bad news is I don't know what the problem is. Other than that, it's in partition and it fails when we have an array 1, 1, 3, 4, and a start of 0 and an end of 1. So that's actually a lot of information that one can chew on. And guess what? This is something you have to think about again. See how long it takes to do such simple debugging?